Hello guys, my name is Akash Putte and you're watching Java for You. So today I'm going to cover a very interesting topic, that is object-oriented programming, and also I will be covering the three OOP principles, that is encapsulation, inheritance and polymorphism. So guys, if you want the detailed information about these topics, then watch the video till the end so that you will get to know each and every part of the OOP principles. So especially for the freshers to the Java, it would be a great video because I have given the real world examples. I guess you might be wondering, I have given a car picture here and also interiors of car picture here. It is somewhere related, so I'll be explaining this part in the video. So let's begin. So object-oriented programming. Object-oriented programming, that is OOP, is at the core of Java. In fact, all Java programs are to at least some extent object-oriented. OOP is so integral to Java that it is best to understand its basic principles before you begin writing even simple Java programs. Therefore, this video I'll be discussing the theoretical aspects of OOPs. Okay. So the two paradigms we have, that is all computer programs consist of two elements, that is code and the data. Furthermore, a program can be conceptually organized around its code or around its data. That is, some programs are written around what is happening and others are written around who is being affected. These are the two paradigms that govern how a program is constructed. The first way is called the process-oriented model. This approach characterizes a program as a series of linear steps, that is the code. And the process-oriented model can be thought of as a code acting on the data. Procedural languages such as C employ this model to considerable success. However, the problems with this approach appear as programs grow larger and more complex. So to manage increasing complexity, the second approach is called the object-oriented programming, and it was conceived, that is, object-oriented programming organizes a program around its data, that is the objects, and a set of well-defined interfaces to that data. That is, an object-oriented program can be characterized as data controlling access to the code. As you will see, by switching the controlling entity to data, you can achieve several organizational benefits. So, coming to the abstraction. What is abstraction? Yes, I will explain it in detail. And you might be wondering, I have given the pictures of the car. Yeah, just listen carefully so that you will get to know each and every point of what abstraction is and how it is applied. Alright, so an essential element of object-oriented programming is abstraction. Humans manage complexity through abstraction. For example, people do not think of car as a set of tens of thousands of individual parts. Do you think? I don't think so. They think of it as a well-defined object with its own unique behavior. As soon as we imagine a car or think of a car, what we think is a drive, a long drive, isn't it? Do we think of what car has or what parts it has, how many nut and bolts it has? No, no one does that, right? So this abstraction allows people to use a car to drive to a grocery store without being overwhelmed by the complexity of the parts that form the car, isn't it? They can ignore the details of how the engine, the transmission, and the braking systems work. Instead, they are free to utilize the object as a whole, that is a car. So, a powerful way to manage abstraction is through the use of hierarchical classifications. This allows you to layer the semantics of complex systems, breaking them into more manageable pieces. From the outside, the car is a single object, isn't it? Once inside, you see that the car consists of several subsystems. That is, what all you see inside a car: a steering, brake, a sound system, seat belts, a heating cellular phone, and so on. So in turn, each of these subsystems is made up of more specialized units. For instance, the sound system consists of a radio, isn't it? And a CD player or a tape or MP3 player. The point is that you manage the complexity of the car or any other complex system through the use of hierarchical abstractions. So hierarchical abstractions of complex systems can also be applied to computer programs. The data from a traditional process-oriented program can be transformed by abstraction into its component objects. A sequence of process steps can become a collection of messages between these objects. Thus, each of these objects describes its own unique behavior. So you can treat these objects as a concrete entities that respond to messages telling them to do something. That is, this is the essence of object-oriented programming. So object-oriented concepts form the heart of Java, just as they form the basis for human understanding. So it is important that you understand how this concept translate into programs. So as you will see, an object-oriented programming is a powerful and natural paradigm for creating programs that survive the inevitable changes accompanying the life cycle of any major software projects, including conception, growth, and aging. For example, once you have well-defined objects and clean, reliable interfaces to those objects, you can gracefully decommission or replace the parts of an older system without any fear, isn't it? So, it was a brief about abstraction. So, let's come to the very important topic of Java and an interesting topic as well, that is the three O principles. So among them, the first one is encapsulation. So encapsulation is the mechanism that binds together code and the data it manipulates and keeps both safe from outside interference and misuse. One way to think about encapsulation is a protective wrapper that prevents the code and the data from being arbitrarily accessed by other code defined outside the wrapper. Access to the code and data inside the wrapper is tightly controlled through a well-defined interface. To relate this to the real world, consider the automatic transmission on an automobile. It encapsulates hundreds of bits of information about your engine, such as how you are accelerating, the pitch of the surface you are on, and the position of the shift lever. You, as the user, have only one method of affecting this complex encapsulation, that is by moving the gear shift lever. You can't affect the transmission by using the turn signal or windshield wipers. For example, that is the gear shift lever is well-defined interface to transmission. Further, what occurs inside the transmission does not affect the objects outside the transmission. See, like for example, shifting gears do not turn on the headlights. So when you shift the gear, do you see any change in the headlight? Do you see the is the the headlight changed? Turned on or turned off? No, isn't it? Because an automatic transmission is encapsulated, dozens of car manufacturers can implement one in any way they please. That is, However, from driver's point of view, they all work the same. This same idea can be applied to programming. The power of encapsulated code is that everyone knows how to access it and thus can use it regardless of the implementation details and without fear of unexpected side effects. In Java, the basis of encapsulation is the class. Although the class will be examined in the, in detail in my upcoming videos. So I'll be here. I'll be discussing, in brief, that is about the class, so that we'll get acquainted for what I'm saying, and it will be easy for you to understand in my next video. So a class defines the structure and the behavior, that is the data and the code that will be shared by a set of objects. Each object of a given class contains the structure and the behavior defined by the class, as if it were stamped out by a mold in the shape of the class. For this reason, objects are sometimes referred to as instances of class. Thus, a class is a logical construct and an object is the physical reality. When you create a class, you will specify the code and the data that constitute that class. Collectively, these elements are called members of the class. Specifically, the data defined by the class are referred to as member variables or instance variables. The code that operates on that data is referred to as member methods or just methods. See, if you are familiar with C or C++, it may help you to know that what a Java programmer calls a method and a C++ or a C programmer calls a function. In properly written Java programs, the methods define how the member variables can be used. This means that behavior and interface of a class are defined by the methods that operate on its instance data. So since the purpose of class is to encapsulate complexity, there are mechanisms for hiding the complexity of the implementation inside the class. So each method or a variable in a class may be marked as a private or a public. The public interface of the class represents everything that external users of the class need to know or may know, and the private methods and the data can only be accessed by the code that is member of that particular class. So in my upcoming videos, I'll be covering in detail about what is private, public, and we have a few more access specifiers. I'll be making an in-depth video for that as well. So therefore, any code that is not a member of class cannot access a private method or variable. Since the private members of class may be accessed by other parts of your program through the class, public methods, you can ensure that no proper actions take place. Of course, this means that the public interface should be carefully designed not to expose too much of the inner workings of the class. So coming to the next principle, that is the inheritance. Yeah, before that I would like to explain you the public, private and the private methods, that is in brief. Okay, so you can see a diagram here. All right, so in this diagram you can see that the white transparent triangles, the white triangles which are at the border are the public methods. So they can be accessed by everyone in that particular class or the program. So private methods are accessible. The black triangles you can see here, private methods are accessible only by that particular class or method. So these are the private instance variables, and public instance variables, which we do not recommend usually, while programming or while coding a program. So coming to the inheritance, I will just brief you with it, and I will explain this diagram what it means. Right? I guess you must be understanding, because I have taken it I mean in terms of layman, that is animal, mammal, canine, domestic. I guess you might be guessing what is happening here. So I will be mixing the real world and the programming, and I'll just brief you with what inheritance is. So inheritance is the process by which one object acquires the properties of another object. This is important because it supports the concepts of hierarchical classification. As I mentioned earlier, most knowledge is made manageable by hierarchical, that is top-down classifications. For example, a golden retriever is a part of the classification dog, which in turn is the part of mammal class, which is under the larger class animal. Without the use of hierarchies, each object would need to define all of its characteristics explicitly, and it is impossible. Like for example, you have bought a dog, okay, a golden retriever. You go to your friend and you do not explain him that it is a mammal, it is an animal, it has 4 legs, and it is a golden retriever. Okay, you just say I have bought a dog, golden retriever, and he understands what you meant. So that is what I'm trying to explain here. However, by use of inheritance, an object need only define those qualities that make it unique within its class. So it can inherit its general attributes from its parent. Thus, it is the inheritance mechanism that makes it possible for one object to be a specific instance of more general case. Let's take a closer look at this process. See, most people naturally view the world as made up of objects that are related to each other in a hierarchical way, such as animals, mammals, and dogs. If you wanted to describe animals in an abstract way, you would say that some attributes such as size, intelligence, and type of skeletal system. Animals also have a certain behavioral aspects, that is, they eat, they breathe, they sleep. This description of attributes and behavior is the class definition for animals. Okay, so if you wanted to describe more specific class of animals such as mammals, they would have a specific attributes such as a type of teeth and mammary glands. This is known as subclass of animals, where animals are referred to as mammals of superclass. Since mammals are simply more precisely specified animals, they inherit all of the attributes from animals. A deeply inherited subclass inherits all of these attributes from each of its ancestors in the class hierarchy. Inheritance interacts with the encapsulation as well. If a given class encapsulates some attributes, then any subclass will have the same attribute plus any that it adds as a part of its specialization. So this is a key concept of that is that lets object-oriented programs grow in a complexity linearly rather than geometrically. A new subclass inherits all of the attributes of all its ancestors. It does not have unpredictable interactions with the majority of rest of the code in the system. So I guess by the explanation which I gave, it was given now, I guess you have got what this diagram means. So we have the superclass animals, and we have the subclass mammal and reptile. Under mammal we have the subclasses canine and feline, and under the class canine we have the subclasses domestic and lupus, and under domestic we have the retriever and the poodle, and then under retriever we have the labrador and the golden. So that's it, the inheritance, and let's start with the polymorphism. It's a Greek word. The name suggests poly means multiple, that is one interface and multiple methods. Yeah, you might be wondering what in the polymorphism I have taken the pictures of the dog. Yeah, to make it interesting I have taken it, but I have related polymorphism with the real world examples so that you can understand it better. And so let's begin with polymorphism. Polymorphism is a feature that allows one interface to be used for general class of actions. The specific actions is determined by the exact nature of the situation. So consider stack, okay, which is last in first out list. You might have a program that requires three types of stacks. One stack is used for integer values, one for floating point values, and one for characters. The algorithm that implements each stack is the same even though data being stored differs. In a non-object-oriented language, you would be required to create three different set of stack routines, with each set using different names. However, because of polymorphism, in Java, you can specify a general set of stack routines that all share the same names. More generally, the concept of polymorphism is often expressed by the phrase, one interface, multiple methods. This means that it is possible to design a generic interface to a group of relative activities. This helps reduce complexity by allowing the same interface to be used to specify general class of the action. It is compiler's job to select the specific action, that is the method, as it applies to each situation. You, the programmer, do not need to make this selection manually. You just need only remember and utilize the general interface. See, extending to the dog's analogy, okay? A dog's sense of smell is polymorphic, isn't it? Do you want to know how? Yes, it is. I will explain you that. If the dog smells a cat, it will bark and run after it, isn't it? If the dog smells a food, you can see here, okay? If the dog smells its food, it will salivate and run towards its bowl. The same sense of smell is at work in both the situations. The difference is that what is being smelled, that is the type of data being operated upon the dog's nose. Okay, this same general concept can be implemented in Java as it applies to methods within a Java program. So yeah, I forgot to put one slide, that is anyways, I'll just explain it. The polymorphism, encapsulation and inheritance work together in most of the programs. So I will explain you how it works. When a properly applied polymorphism, encapsulation and inheritance combine to produce a programming environment that supports the development of far more robust and scalable programs that does the process-oriented model. A well-designed hierarchy of classes is the basis of reusing the code in which you have invested time and effort developing and testing. See, encapsulation allows you to migrate your implementations over the time without breaking the code that depends on the public interface of your classes. And polymorphism allows you to create clean, sensible, readable, and resilient code. Of the two real-world examples, the automobile more completely illustrates the power of the object-oriented design. Dogs are, of course, fun to think about from an inheritance standpoint, but cars are more like programs. All drivers rely on inheritance to drive different types, that is a subclass of the vehicles. See, whether the vehicle is a school bus, a Mercedes-Benz or a sedan, a Porsche or the family minivan, drivers can all move more or less, find and operate the steering wheel, the brakes and the accelerator. After a bit of gear grinding, most people can even manage the different between a stick shift and an automatic, that is the manual and the automatic, because they fundamentally understand their common superclass, that is they need to transmit, that is the transmission, change the gear, isn't it? Maybe a sedan or a Benz or a XUV or whatever it is. Their main motor intention is transmission of gear. So people interface with encapsulated features on all cars all the time. The brake and the gas pedals had an incredible array of complexity with an interface so simple you can operate them with your feet. The implementation of the engine, the style of the brakes and the size of the tires have no effect on how you interface with the class definition of the pedals. The fine attribute polymorphism is clearly reflected in the ability of car manufacturers to offer a wide array of options on a basically the same vehicle. See, I'll give you another example. So you can get an anti-lock braking system, alright, or a traditional brakes, power or rack and pinion steering, and 4, 6 and 8 cylinder engines. Either way, you will still press the brake pedal to stop. It's not like you are having a 6 cylinder engine and you apply brake for acceleration, or you have the 8 cylinder engine, you apply clutch to stop the vehicle. It's not the case, isn't it? Either way, you will still press the brake pedal to stop and the turning steering wheel to change the direction and press the accelerator when you want to move. The same interface can be used to control the number of different implementations. As you can see, it is through the application of encapsulation, inheritance and polymorphism that individual parts are transformed into the object known as a car. The same is also true of computer programs. By the application of object-oriented principles, the various parts of the complex program can be brought together to form a cohesive, robust, maintainable as a whole. So as I mentioned at the start of this video, every Java program is object-oriented, or put more precisely, even Java program involves encapsulation, inheritance and polymorphism. Although the short example programs shown in the rest of my videos and in the few upcoming videos may not seem to exhibit all of these features, they are nevertheless somewhere present. So as you will see, many of the features supplied by Java are part of its built-in class libraries, which do not make extensive use of encapsulation, inheritance and polymorphism. So that's it guys with the OOPS principle, and if you have any doubt regarding the same, you can let me know in the comments section below. I will definitely address it as soon as possible. So before I wind up this video, I would like to tell you that thanks for watching the video. Don't forget to like, comment, subscribe and share. Yeah, I forgot one thing. In my next video, I'll be coming up with the first program. Yeah, I know you guys might be bored of the theory part. So finally, we'll start with our first program. It will be a very simple program, 4 lines of code, but I will explain you thoroughly how, what it does, right from the first curly braces to the last curly braces. So guys, stay tuned for more such videos. Till then, bye bye, have a nice day.